Today I'm going to go through how we can construct a hypothesis test by just looking at an example where a teacher thinks that only 20% of the pupils in the school watch the news regularly. He chooses 25 pupils at random and finds that 10 of them are watching the news regularly. Test at the 5% level of significance whether or not there is evidence that the percentage of pupils who watch the news is more than 20%. State your hypotheses clearly. So, the first thing I'm going to do is I'm going to make sure that I write down what my null and my alternate hypothesis are. Well, my null hypothesis is going to be what we assume to be true. So a teacher thinks that only 20% of people, so therefore my probability of people watching the news would be equal to 0.2. And that would be my null hypothesis. My alternate hypothesis would be that this is actually not the probability, it would indeed be, more than 20% because this final line says percentage of people who watch the news is more than 20%, so it'd be greater than 0.2. Once I've done this, I'm going to first of all write a few things that I know. I know that my significance level is going to be equal to 5%, and I'm just going to write that as a decimal, which is 0.05, and I would also know that this would be a one-tailed test. The reason I know that, and you can check this yourself, is because we are indicated which direction of a tail we are looking for. If you imagine the normal distribution, or the binomial distribution in this case, we would be expecting greater than 0.2, so we would be wondering if 10 people would in fact be greater than this. So we are looking at one tail. Okay, so before I conduct this test, I want to think about what it is that I'm actually trying to define. In terms of this scenario, I'm trying to see if 10 people is less likely than 5% to happen, given that we would only expect 25 pupils and 20% would be 5. So we would expect 5 people to watch the news from this teacher. However, we found out that 10 people. So I want to know, is that a less than 5% chance of happening? So in order to do that, I'm going to look at distributing this model binomially. And the amount of students I have, which is n, would be 25. And my probability of p, well, I'm assuming h0 is true. So for this case, it would be 0.2. The amount of people that I have which are watching this would be my probability. So the probability that x is going to be greater than or equal to 10. And now I know that when I'm looking at a cumulative probability, I can only work with less thans. So that must be equal to 1 take away the probability that x is less than or equal to 9. So when I do this, I'm just going to work this out on my calculator. The probability that x is less than or equal to 9 is 0.9827, so 0.9827. And when I work that out, that gives me 0.0173. So therefore, the chance that this would happen and I would get 10 people if my probability was 0.2 would be a 1.73% chance of happening. Now, we're testing at the 5% level. So I want to check whether this is going to be less than or equal to or greater than or equal to 5%. That is how I will make my hypothesis. Hopefully we know that this is less than 5%. So therefore we would have sufficient evidence at this significance level to reject h0. So I would say at this significance level we have sufficient evidence to reject h0. To reject h0 and accept our alternate hypothesis and accept h1. So therefore, After this test has been conducted, I have sufficient evidence to reject my H0 and also accept my alternate hypothesis that the probability would indeed be greater than 20%. Thank you again for watching. If you have any comments, let me know in the description box or even email me. Thank you very much, and I'll see you in the next video.